Hi guys, I want to take a moment and show you guys a free online graphing tool online called Desmos, and at the same time we'll be able to kind of investigate some of the problems that we did in 2.1 and 2.2. So right up here I'm just going to type in DESMOS, Desmos, and I jumped right to it. Let's see what would happen if I just type it into Google this way, Desmos. And then, yeah, Desmos, beautiful free math right there. There's also an app, looks like this, you can get on your phone. Believe it's free. They used to charge a couple bucks, but I believe they made it free now. Okay, so I'm just going to right over to the website and then click the graphing calculator. And okay, here's what it is. So it's pretty nifty. We're just going to type things in up here, and then we can go and kind of view the graph and zoom in, zoom out. There's a lot of features here, but let's just get to it. So we were looking at in 2.1, we saw the limit of 5x squared as x approaches 3. So if I type in y equals 5x, and for the squared, I'm going to use the caret. There's 5x squared. Okay. And we wanted, in question was, as x approaches 3, and as I zoom out, I can see, oh, 3 is going to be way up there. I think our answer was 45 to that one. And so we'll be able to see the point at 3, about right there. Where is it? 345. Okay, well, it's hard to pinpoint it exactly. You can also type in an ordered pair here into Desmos, which is pretty cool, and it highlights right there. There's 345. Okay. Yeah. But really the point being, we can see there's no holes, there's no jumps. Okay, the next one we did, a little bit more interesting, was this rational function. It was x squared minus x minus 6 over x minus 3. And now surprising, the graph of that is just a straight line. That's bizarre. We were looking at first, the limit as x approaches 0. Well, and the answer to that was 2. We could just plug the 0 in. Zoom in a little more. And then in part C, the limit as x approaches 3. So here's 3, right? So if I hover over that, and again, let's try to pinpoint it. It's hard to do, but okay, 3. Oh, you notice, I don't want to move my cursor, but you see there's a hole right there. It's undefined. Well, because we would be dividing by 0. In fact, it'd be 0 over 0, so it gives a hole. In fact, if we tried to plug in 3, we wouldn't get an answer. It looks like 3 is occurring right there at 5, right? So if I put in 3 comma 5, oh, looks like a little messed up there. Okay. We can see there's a point at 3, 5, right? But the green line, if I click that, it'll get rid of it. The green line, it looks all fine, but then when I highlight, it gives that hole. Now, it's an infinitely small hole, so that's why it doesn't show here. But when I highlight it, yeah, there it is. Oh, there it is. Okay, we've seen it. But it turns out if you factor and simplify, you end up, here was the factored and simplified version. X plus 2. And you notice it's exactly the same line, except now on the black line, that hole has been filled in. And we can plug in x equals 3 and get 5 as our answer. Okay. Moving on, let's look at a couple things from 2.2. So we saw those limits, infinite limits and limits at infinity. So the first one that we did in part A, it said determine the infinite limit. We were looking at 1 over x minus 3. So I'm going to graph y equals 1 over x minus 3. And by the way, for that division symbol, I'm just using the slash on my keyboard, and it looks really nice. Okay, so there we go. And yes, we can see there's a vertical asymptote there at 3. Now, we did this problem without seeing the graph. We did it with a table. So be prepared to use a table on your test or a quiz. However, it's nice to look at the graph as well just to kind of get a fuller picture. So we were looking at the limit as x approaches 3 from the right. So we're looking on the right side of 3, and we can tell, yes, that's going up to positive infinity. And indeed, that is what the table revealed to us as well, that as we took values bigger than 3, but then let them come back and approach 3 from this side, those y values were getting bigger and bigger and bigger. We also did a harder version. We did 4x squared plus 2x squared minus 9x minus 5. We see, okay, yep, there's another vertical asymptote. This time it's happening at 5. We were looking as x approaches 5 from the left on this side, and yep, it's going down to negative infinity. Of course, we did it with a table. Finally, we did end behavior, limits at infinity to finish off 2.2. So we had this one, a lot of rational functions for us, a lot of interesting behavior. We did this one right here, 5x to the third minus 1 over 8x plus 3, and kind of a bizarre graph there, but we were thinking, okay, what is the limit as x approaches infinity? So going off in this direction, so ignoring all this stuff, just as x gets bigger and bigger, and yes, indeed, that function, the y value, shoots off to infinity as well. How about as x approaches negative infinity? Well, kind of in a similar way, as we go back to the left here, as x approaches negative infinity, the y value shoots up to positive infinity again, and we got that. And then the very last question we did was y equals, we had 3 plus x plus 2x squared was over 5 minus 3x to the 5th. And okay, we did the limit as x approaches infinity. So again, kind of this interesting behavior, kind of a little bump. That's kind of cool. But we're really interested in this. As x gets bigger and bigger and bigger, what's happening to the function? And it's approaching 0. There's a horizontal asymptote there. And it looks like it's just becomes the x-axis, but no, actually it's approaching, never actually reaches it. But it sure is coming into 0 quickly as x gets large. Okay. So, hey, as you're doing homework, take advantage of Desmos. And if you recall, when you're doing quizzes and tests, you're only allowed to use Desmos as your work in questions that I specifically say that that's okay. But you can always use Desmos for anything to kind of get a fuller picture of what's going on, even on tests and quizzes. But it might not suffice to say, well, I graphed it, so here's the answer, right? So kind of like, those questions we did with the infinite limits, something like y equals 1 over x minus 3. I don't want you to just graph it and then tell me the answer from the graph. I'd want you to use the table. But it's perfectly fine to graph it to confirm your answer from another method, or to just get a fuller picture of what's going on for other reasons as well. Okay, guys, hey, take a look at Desmos. Really just kind of nifty. There's a lot of features, and it's easy to get lost, but very user-friendly at the same time. All right, that's it.